So now, here we have an NPN bipolar junction transistor. I'm using the 2N3904 wired as a switch. So the LED is off right now because the transistor is off. We need a little bit of base to emitter current right there. That's a 10K resistor. And we got a lot more current now going through the load. The load is actually limiting the current. The transistor will let more current through than what the load demands. So we have the circuit over there. So you need a little bit of base to emitter current. With no base to emitter current, the transistor is off. That is called cutoff. It's not going to let any current flow through. Now, if you get some base to emitter current flowing, we got a little less than half of a milliamp right there. That gets the transistor collector to emitter conducting much better, maybe 100, 200, 300 times as much. But in this case, the load is going to limit the current. So we're going to get about 20 milliamps of current through this load. So now, the 2N3904 has this pin layout right there. Left pin emitter, middle pin base, right pin collector when you're looking at the flat side right there. And that's the schematic symbol right there, collector on top, base to the left there, and emitter to the bottom there, although it can be swiveled around as needed. But the emitter is where the arrow is. That's the main thing. And hopefully there's a part number whenever you see the schematic diagram. You don't have to use that part number, but you can. You have to use an equivalent, for the most part, or a better one. So in any case, if you can't read the part number, you can always use a loop or a magnifying glass. Now, as I said before, the emitter is to the left. So in this case now, I would have to turn it like this way. Now the emitter is at the bottom, as you can see there. And we will come over, and this is how you just plug it into the board, just like you saw with the schematic right there. I gave it a little bit of a false signal, but we give, a semi-weak signal there, and it turns the transistor on. So now, as we said, the NPN bipolar junction transistor is off with no base to emitter current. A small base to emitter current allows many times the collector to emitter current. So there you can see, no base to emitter current, no collector to emitter current, and a little bit of base to emitter current allows a lot more collector to emitter current. So we can kind of calculate it in worst case scenario. So we got 5 volts minus a diode drop from the base to emitter, and then the 10,000 ohm base resistor. So that's how we got our 0.43 milliamps of current. So what matters now is how much current the transistor will let through. Worst case scenario, it has a gain of 100, maybe it's 200, maybe it's even 300. But we're going to go worst case right there. So 0.43 milliamps of current times 100 means that it will let at least 43 milliamps of current flow through. The load is limiting it. So we have, with the load there, about 20 milliamps of current.